Welcome, future colleagues. Listen, whether you're charting a brand new patient, consulting with a specialist on a complex case, or just flipping through a file, there is one absolute rule in dentistry: accuracy is everything. Today's explainer is all about charting and recording cases. Specifically, we're going to master the tooth numbering systems that literally act as the universal language of our entire profession. So let's just get right into the practical challenge here. Picture this: a completely packed, loud clinic. Imagine the absolute chaos of trying to communicate if we didn't have a standardized way to identify one single tooth. I mean, we've got 32 permanent teeth and 20 primary teeth to keep track of. If an oral surgeon extracts the wrong tooth just because of some messy handwriting on a chart, yeah, that is a catastrophic clinical failure. We need systems that are completely foolproof, incredibly easy to grasp, and lightning fast to record. To get us to that foolproof level, today's explainer is going to cover four things: the Zsigmondy-Palmer system, the universal system, the FDI two-digit system, and we'll wrap it all up with the nomenclature of tooth surfaces. All right, let's kick things off with Section 1, the Zsigmondy-Palmer system. Now, this one is an oldie but a goodie. It basically maps out the mouth using a visual quadrant grid. It was originally designed way back in 1861 by an Austrian dentist named Zsigmondy, and then tweaked a bit by Palmer in 1891. And honestly, it has serious staying power. You're still going to see this heavily used today by orthodontists, dental students, and practitioners, especially if you're practicing over in the UK. What's great is how Palmer elegantly separates the two types of dentition. For primary, or baby teeth, the system uses the letters A through E, starting right at the midline and moving straight back. For the permanent teeth, it switches to numbers 1 through 8. Again, you start right at the midline central incisor and count your way back to the third molar. Simple, right? But here's how this actually looks in clinical notation. Palmer relies on drawing a specific little bracket for each quadrant. Think of it like a crosshair over the mouth. The vertical line represents the patient's midline, and the horizontal line is the bite line, or occlusal plane. So a right angle bracket that closes off the bottom left, that tells you you're looking at the patient's upper right quadrant. Visually locking in the orientation of these lines is absolutely essential, because the shape of the symbol itself tells you exactly which corner of the mouth you're working in. A bracket that's open to the bottom right maps perfectly to the patient's upper left quadrant. The trick here is to always imagine you are looking directly at the patient's face. From there, you just drop a number into the bracket, and boom, you have pinpointed your tooth. A bracket opening to the top right, that designates the patient's lower left quadrant. Honestly, the true elegance of this system is how it functions as visual shorthand on paper. This final bracket, the one open to the top left, represents the lower right quadrant. Drawing just one of these four brackets with a quick number inside lets a dentist instantly and perfectly convey a specific tooth on a physical chart. But let's be real for a second. Imagine trying to type an upper left Palmer bracket on a standard computer keyboard. Yeah, good luck. It's a total clinical headache. That's the major drawback of the Zsigmondy-Palmer system. The visual symbols make it notoriously difficult for verbal transmission and digital record keeping in a modern, fast-paced clinic. Which naturally brings us to Section 2, the universal system. We aren't going to do a massive deep dive into this one today, but it is absolutely vital to know it exists. Also known as the national system, it's widely used in the United States. It's super straightforward. It just numbers permanent teeth sequentially from 1 to 32, starting at the upper right third molar and wrapping around to end at the lower right third molar. For primary teeth, it uses the exact same sequence, but with letters A through T. You definitely need this in your foundational toolkit alongside Palmer. All right, moving on to Section 3. The FDI two-digit system. Now this one is a real game changer. It has truly become the worldwide standard for tooth numbering. When you compare it to Palmer, the FDI elegantly solves that whole verbal transmission problem by relying completely on a user-friendly two-digit numerical code. No brackets to draw, no weird shapes to try and describe out loud, just two simple numbers spoken one after the other. Introduced back in 1971, this system checks all the boxes set by a special FDI committee, and it is accepted globally by massive organizations. We're talking the WHO, the ISO, and the ADA. The advantages are pretty undeniable. It completely prevents left versus right confusion. Every single tooth gets a totally unique ID, and most importantly for today's world, it is incredibly easy to type into modern dental software. Let's ground this theory in clinical reality for a second. When you look at how the numbers map directly onto a patient's bite, it just makes sense. The mouth is divided right down the middle, and straight across the bite line. Each of the 4 quadrants gets its own specific starting number, and then the teeth are just numbered sequentially as you move away from that center line.
The underlying logic here is beautiful. It's so systematic. The first digit always indicates the quadrant. For permanent teeth, you use 1 through 4, going clockwise starting from the patient's upper right. For deciduous or baby teeth, those quadrants are numbered 5 through 8 in that exact same clockwise direction. Then your second digit indicates the actual tooth type, from 1 to 8 for permanent teeth or 1 to 5 for primary teeth, counting from the midline backward.
Mapping this out onto a complete permanent arch reveals just how easy this is to memorize. Upper right is quadrant 1, so the central incisor is 11, going back to the third molar at 18. Upper left is quadrant 2, giving us 21 to 28. Lower left gives us 31 to 38, and lower right wraps it up with 41 to 48. See? It completely eliminates any confusion about left, right, upper, or lower.
Though just a quick heads up for your studying. While it is highly accurate, memorizing those 5 through 8 quadrant prefixes for primary baby teeth can feel a little clunky at first. It's going to require just a bit of extra drill work to make sure you instantly recognize that, say, tooth 54 is a primary first molar in the upper right quadrant.
Okay, rounding out today with section 4, nomenclature of tooth surfaces. Because listen, once you know the tooth number, whether you're using Palmer, Universal, or FDI, you still have to describe its specific surfaces. You can't communicate accurately about cavities, restorations, or pathologies without this. Think of these terms spatially. Buccal faces the cheek. Labial faces the lip. You'll often hear facial used as a catch-all term for either of those. Then we have the directional surfaces. Mesial is the surface moving towards the midline, while distal faces away from the midline. Finally, the lingual surface is the inside face of the tooth, resting right against the tongue. By combining the exact tooth number with the precise surface, like saying mesial decay on tooth 46, you're creating an unbreakable chain of clinical communication. So as you pack up and head into your clinical labs, consider the systems we cover today. Knowing that a single charting error could mean extracting the wrong tooth, which of these numbering systems do you trust to be absolutely foolproof in your own hands?